Hello and welcome to yet another video of Cornerstones of Math. These are pies. These are households. And we want to distribute these pies to these households. Based on this setting, we are going to solve these 7 problems. Now you don't have to pause the video and read all of these. You are going to read all of these problems as I explain them one by one throughout the video. So let's dive right into the first problem. You want to distribute 3 distinguishable pies to 3 households. How many ways are there to distribute the pies so that each household receives exactly 1 pie? Well, this one is really easy. There are 3 choices for the first pie. But once the household for the first pie is chosen, there are only 2 choices left for the second pie. And then there is only 1 choice remaining for the third pie. So the number of ways is 3 times 2 times 1, or 3 factorial. Next, the second problem. You want to distribute 3 distinguishable pies to 5 households. How many ways are there to distribute the pies so that each household receives 0 or 1 pie, and there are no remaining pies? The thing is, this problem is designed to apply the same pies choose households approach as the previous problem. So there are 5 choices for the first pie, then 4 choices for the second pie, and then 3 choices for the third pie. So there are total 5 times 4 times 3 ways, which is the permutation 5 permute 3. So we have 60 ways. Next, the third problem. You want to distribute 3 distinguishable pies to 5 households. Each household can receive any number of pies including 0, and there must be no remaining pies. How many ways are there to distribute the pies? We start the same way. The first pie has 5 choices. But here's the part where it becomes different from the previous problem. Since each household can receive any number of pies, the second pie still has 5 households to go, including this household that has been already chosen. The same goes for the third pie as well. So the number of cases is now 5 times 5 times 5, or 5 cubed. This is the permutation with repetition. That is, the number of ways to choose 3 from 5 distinct elements and arrange them linearly. So here we have 125 ways. The next problem is, you want to distribute 3 indistinguishable pies to 5 households. So now the pies look exactly the same. How many ways are there to distribute the pies so that each household receives 0 or 1 pie, and there are no remaining pies? Well, in this case, instead of each pie choosing the households, we simply choose 3 households from these 5, so that each chosen household gets a pie. Therefore, the answer is the number of ways to choose 3 households from 5, which is 5 choose 3, which equals 5 times 4 times 3 divided by 3 factorial. So we have 10 ways. At this point, the next problem is obvious. You want to distribute 3 indistinguishable pies to 5 households. Each household can receive any number of pies including 0, and there must be no remaining pies. How many ways are there to distribute the pies? Well, the method is similar to the previous one. We choose 3 households from these 5, but this time we allow the repetition. That is, the same household can be chosen more than once. This is the combination with repetition. In our case, we choose 3 out of 5 allowing the repetition, and such number of ways is denoted by using double parentheses, which often read 5 multi-choose 3. And the number of combinations with repetition can be computed by this formula, that n multi-choose r is equal to n plus r minus 1 choose r. In case you wonder how this formula is derived, someone made a really good video about that. Anyway, using this formula, 5 multi-choose 3 is equal to 5 plus 3 minus 1 choose 3. So 7 choose 3. So we have 35 ways. Alright, what's next? In problem F, you want to distribute 5 indistinguishable pies to 3 households, so there are more pies than households. Each household must receive at least 1 pie, and there must be no remaining pies. How many ways are there to distribute the pies? The key here is that each household must receive at least 1 pie, so having 0 pies is not allowed. Well, in that case, we can start by giving each household a pie, so that each household has at least 1 pie. Then there are 2 pies remaining, and we simply distribute these 2 indistinguishable pies to 3 households. This is the combination with repetition, the number of ways to choose 2 households that are going to receive the pies, where the same household can be chosen twice. So we have 3 multi-choose 2, which is equal to 3 plus 2 minus 1 choose 2, which is 4 choose 2, so we have 6 ways. And the last problem, which is probably the most complicated one. Here we are back to distinguishable pies. You want to distribute 5 distinguishable pies to 3 households. Each household receives 0 or 1 pie, and the striking difference here is that there can be remaining pies. How many ways are there to distribute the pies? The key to solve this rather complicated problem is that each household receives 0 or 1 pie. So let's suppose that k households receive 1 pie each. Then 3 minus k households receive no pies. Here k can have values of 0, 1, 2, and 3. In this case, there are 3 choose k ways to choose k households that receive 1 pie each. Once the households are chosen, we then choose which households receives which pie. The method is that we choose k pies from 5 pies and then arrange them linearly so that they can be distributed to k households. The number of ways is the number of permutation 5 permute k. This means that there are 3 choose k times 5 permute k different ways that k households receive 1 pie each. Since k can have the values of 0, 1, 2, and 3, the total number of ways is the summation of this, where k goes from 0 to 3, so it is 3 choose 0 times 5 permute 0, plus 3 choose 1 times 5 permute 1, plus 3 choose 2 times 5 permute 2, plus 3 choose 3 times 5 permute 3. So it is 1 times 1 plus 3 times 5 plus 3 times 20 plus 1 times 60, which gives 136 ways. And that's all for today's video. Thank you for watching. If you want to watch the video where I explain the permutations and combinations using the number of functions, please watch this video at the top. Also, please don't forget to hit that like and subscribe buttons, and as always, I will see you in another video.